to introduce you to, I want to give you a definition that has to do with the example. Definition of skew lines. Okay, so skew lines. Skew lines are lines that let's say that neither intersect nor parallel. Okay? Since, let's take two lines. If two lines lying on the same plane, then they either intersect or parallel. Or they can be coincident, but coincident or parallel lines. That's also accepted. So, how can you find two lines that are skewed, that are neither intersect nor parallel? They are different planes. So the conclusion, skew line can, this implies that the lines are not on the same plane. This definition implies that skew lines do not lie on the same plane. Okay, let's write here in parentheses lines on the same plane have to line on the same plane. There is a little bit of redundancy here, but I just want to make sure that we all on the same page. So line on the same plane, I don't need to close the parentheses. So either intersect or are parallel. Like so. So here's the example. Given two lines in parametric equation form, in PE form, where L1 equals 1 plus T, parametric x equals 1 plus t, y equals something else. So L1 looks like x equals 1 plus t, y equals -2 plus 3t, and z equals 4 minus t, and L2 will be given by x equal 2s. I'm using a different parameter. Y equal 3 plus s, and z equal -3 plus 4s. Okay, so s and t, where t and s are parameters of L1 and L2 respectively. Okay? What we are tasked to do is we need to show that L1 and L2 are skew line. So, the solution. By the definition, they are neither parallel nor intersect. So we need to show that they're neither one of those two conditions. So we're going to start with one. Okay, the first condition. We're going to say that they are not parallel because why? Right. Because their corresponding direction vectors or vector numbers corresponding direction numbers, let's see, the first one is the direction number. Remember, the direction number ABC per the multiply T. So the direction number of L1 is 1, 3, or R, 1, 3, and negative 1. And the direction number of L2, you have 2, and then a 1, and then 4. Okay? And they are not a scalar multiply of each other. Okay? If they were scaled, for instance, direction number 1, 2, 3, and 2, 4, 6 are parallel. Okay? Or 1, 2, 3, and negative 1, 2, negative 1, negative 2, and negative 3 are also parallel. Right? They are scalar multiply of each other. But these two numbers, there is no such a scalar that 1 becomes 2, while 3 becomes 1, and negative 1 becomes 4. So are not scalar multiplication of each other. i.e. their direction vectors do not point in the same direction. Do not point toward the same direction. So we proved that they are no, we show that they are not parallel. Now we need to show that they don't intersect. How we go about finding out whether the two lines are intersect? The x, y, and z has to be shared, right? The same point, x, y, z, lie on both L1 and L2. So let's write number 2. L1 and L2 intersect if there is a point, x, y, z that lie on both lines. So if that's the case, then the x, we have a system of 3 equations. Okay, so what are those? Let's see, what are the equations? 1 plus t must equal to 2s. That's the x value, right? The y value, so this is in x. In y, we have negative 2 plus 3t must equal to 3 plus s. And the z component, we have 4 minus t must equal to negative 3 plus 4s. Okay? You can undo the split, bring it here. Turn out that this system doesn't have a solution. Okay. You can solve. Notice that we have two variables or two unknown with three equations. So we can always find a solution to, well, not always. And if the first two equations, if one is not a linear combination of the other, then there is a solution, right? But for the third equation is the one that is either redundant if there is a solution, or negate the solution for the first two equations. So you can try. This is simple algebra, but we're going to say that this system has no solution. Has no solution. In other words, since the system has no solution, then an intersection does not exist. So the lines are neither parallel nor intersect, therefore the lines are skewed.